In this episode, I'm going to show you how to make Oh, come on. In this episode, I'm going to show you how to make good stamps using only your 3D printer. First up, a quick announcement. A short while ago I made a website so that I can more easily make information and downloads associated with videos like this available to you. If you click the link below, you can go directly to the page associated with this video, where you can get hold of the files used, as well as my TPU profile for Prusa Slicer. I'll be gradually uploading more profiles as time goes on, so look out for that. There's a separate video to announce some other stuff coming up too, so look out for that as well. The last time I tried to make stamps was my first ever video, and it wasn't that successful. Although I managed to achieve some results, I wasn't happy with them. Imprints were fairly poor and unclear, and the stamps weren't transferring enough ink to be that usable. Now, given the overwhelming popularity of that video, and a number of people asking me to try again, I decided I'd give it another go and try and work out what went wrong and whether I can improve on it. Obviously I can, as you've already seen in the intro, so let's just get on with it. I broke out the original stamps from last time so I could look closer at why they didn't work that well. If we look at a professional stamp, or I guess you could call it a commercial stamp as it came from Poundland here in the UK, so professional is probably a stretch, but you can see that the construction is nothing spectacular. However, the rubber is capable of giving smooth prints and really detailed outlines. It's outperforming our last attempts quite a lot. I think we really need to keep our expectations lower than this for a 3D printed stamp. After all, we're not using the ideal material, apparently. But this is an example of peak stamp. It is a good base for comparison. As you can see here on ours, the edges are okay on this stamp, but the texture of the print is very visible and it has lots of missing areas. The edges of the stamp also touch the ink and leave marks on the paper. This was the least worst stamp. If we look at others, we can see that none of them are great. It seems like one of the main issues is that the stamp isn't making constant contact with either the ink or the paper. Or perhaps the material isn't good enough to hold the ink. The latter would be pretty hard to fix, but I suppose not impossible. You could consider coating it. So the first thing I wanted to do this time around was design a system to hold the stamps so that you could have multiple stamps on one handle and switch between them. So I needed to print a decent heavy high infill handle. I did this in Fusion 360. It's actually surprisingly hard to get the right clearance because you are mixing TPU and PLA and they both expand differently when you print them, but I did get there in the end after multiple attempts and quite some tweaking of the spacing between the two parts. So I thought about a number of potential experiments that I would like to run, and thankfully in the end I didn't have to go through all of them because the list was very exhaustive, as you can see on screen now. The main improvements that I wanted to explore was the design of the stamp imprint itself, smoothing the print either with printing techniques or post-processing, flexibility of the stamp itself, orientation of the print, the texture, and the support materials. Just this in itself was quite a list of things to test around, so that's why it took longer than usual to create this video. Take 1 wasn't terribly successful. I tried simplifying the logo and printing in PLA. This honestly wasn't a massively serious attempt as I knew that TPU was probably going to be the better material anyway, but I didn't want to keep having to change filaments, so I decided to start with PLA while doing the handle, and then I could get both the sizing and tolerances mostly sorted out at the same time as I could rule out PLA as a stamp material, which I think I pretty much did. PLA is pretty poor at this. I assume it's just due to the lack of flexibility. Let's take a moment to consider that anyway. I think it's worth talking about at this point. If we see a crude image of a stamp being imprinted, and this is not about the ink, because the ink pad is squishy itself, so any surface would get a good coating of ink. I'm talking about printing it onto a flat sheet of paper. Paper is not really squishy, so any part of the stamp that doesn't make good contact will not leave a good imprint. If you don't have any flexibility in the stamp, nothing can move out of the way in the already squished down parts to let any lower parts touch the paper. So in theory, it makes sense to have a material that allows some compression in this direction pictured in order to get the best impression. This is of course pointing towards TPU, but not just that, the design of the stamp's base also factors in. More on that in a minute. But while we're digressing, if you want to make a stamp logo, I might as well tell you how I did it. I started out in Inkscape and I drew a design. What's important to remember in Inkscape is that any design work you do based on stroke thickness will not transfer to Fusion 360. Fusion 360 sees any stroke as just a line with no depth, so don't waste your time messing around with stroke width, colour, style, etc. Now before you save this, move the whole thing up to the top left corner, because that's what Fusion sees as its 0 point. It makes moving the design around in Fusion a lot easier. And then just save it as an SVG. Once in Fusion, you can simply import the SVG, and I recommend doing this as late as you can in the design, because either I'm stupid, which is quite likely, or you really can't easily move or edit SVG imports after you've placed them, which I found really annoying. Once done, looking from below, you just extrude the design out forward, so that would be a negative extrusion, and the base goes backwards, a positive extrusion. The reason you pull the design down below the plane instead of up is because then it will be reversed. So you don't have to reverse it on import, but if you did want to do that, you can also do that during the import process. The next tests were done with TPU, and they used a more outline-based design with no thicker areas, and these came out better on the whole. I would guess that when you print thin areas of TPU, then it allows a bit of flexing, which means you can get a good coverage. I noticed still though that the legs on the chip here, some bits would miss out quite often, presumably because they were too low to contact, even with that flexibility. We are making progress though. If we do a side-by-side comparison, you can see that this is better. I experimented a little with printing at different depths of TPU, and I couldn't really find a sweet spot where it allowed enough squish without the edges of the stamp touching the paper. It was at this point that I decided to move on to the next test, which was to print the stamps upside down. This is a massive technical challenge for some designs, because not only do you have to get all the letters and fine details to stick down to the bed without moving, but you also have to support the base of the stamp somehow. I will release a separate video in a couple of weeks, more or less, on how to tune your TPU settings to achieve this kind of output. But for now, there's my last TPU video, which appears in the corner here. That should get you some of the way, and also, obviously, I'm sharing my profile as I mentioned. On the second point just mentioned, supporting the base, it's actually not that hard. Because TPU is flexible and soft enough to cut easily with clippers, what I opted to do was to put some circles in the design, just small ones, and extrude them down along with the stamp image. And then once it's printed, you can clip them off. This works really well. I recommend keeping them fairly small because bigger ones are going to be harder to clip off. You essentially want to put them in unsupported corners and where there's large gaps to aid the bridging. Again, having your TPU settings dialed in will help keep this neat. It's actually quite amazing what you can achieve with TPU when everything is working right. So once this was done, I clipped off the support posts and I tried the stamp out. By the way, be sure to use eye protection when clipping off supports. They might be soft, but you still don't want them bouncing in your eye. Now this result is a lot better, but there's something still not quite right. And when I looked in Prusa Slicer's preview, I noticed the obvious mistake I'd made. There's a thing called elephant foot compensation, and this is to control horizontal expansion of the first layer. Without getting too technical, what it's doing is it's messing up the resolution and the thickness of the first layer as it's trying to make it smaller. So I don't want that to happen, it needs to be turned off. This made a massive difference, and at this point I was getting really satisfying results, as you can see here. Compare this to the face up version. Next I wanted to include text, so I did, and it soon became obvious that this stamp was lacking the necessary detail. There's really only two ways out of this. You can either scale up and make the whole stamp bigger, or you could try and increase the detail with higher print resolution. Now since we're printing flat on the plate, the only way to do the second option will be to change down to something like a 0.2mm nozzle. And I did try a 0.2 nozzle with TPU, but I can report that this does not work well at all. TPU and small nozzles is an absolute nightmare. I now have a printer that needs repairing as it's completely bunged up with TPU. Not a big deal, I've left it for later though. The pressure against the nozzle just causes absolute havoc. So the only answer is to scale up, which is what I did next. This time I designed the stamp with the points I'd learned up to now in mind, so this is a point I want to stress, which I will also sum up later on, but it's important to design a stamp that will work well right from the beginning. If you already have a logo, it might not be suitable at all for a stamp, and you're going to struggle to get good results. Bold, simple lines work best without too much detail. This is the logo for my new channel where all my electronics stuff will go. This is part of the announcement that you're going to see in the other video. And yes, I pretty much designed the logo for a stamp, and that will be the channel logo. I guess that's just how it goes sometimes. I was very pleased with this. This turned out to be a perfectly usable stamp. You wouldn't even know this was 3D printed. At this point I also realised that to create a circular stamp, you could save a lot of effort by just using a circular base. So back in Fusion 360, I made a circular handle, and I went with an overall diameter of 48mm. A circular handle is easy enough to make, just draw half of the rough shape and then revolve it. I honestly don't know why I didn't do this to start with, it's so much easier. Once the stamp and the base were completed, I used standard superglue to stick them together. You need about 3 hours for this to dry, during which time it's absolutely necessary to clamp the stamp face down onto a flat surface. Oddly, once this was glued and dry, I found that the circular stamp didn't work as well, and it took me a while to work out why, because there certainly wasn't anything wrong with the stamp handle or the adhesion or anything like that. And after some experimentation, I found out that it's actually to do with the squishiness not only of the letters, but the base behind the stamp. As I mentioned before, the whole stamp has to contact the paper to get a good impression, we know that, and the base is kind of a mattress behind the letters. It was at this point that I started to mess about with different depths of printing and infills, and I realised that the best way is to use an infill that allows a vertical displacement, so a kind of compression, and this would be something like a gyroid infill. You can't infill the stamp detail, it's too thin, and I don't think that would be necessary anyway. You just need enough behind the stamp's design to allow the functional parts of the stamp to push back into it. As a side point, if your printer is struggling to print out some of the letters, as I found was the case with some of the thinner letters on this stamp, like the I kept ripping off after a couple of layers and then ruining the whole print, the answer to this is to either slow down a lot more, which is not a bad idea anyway with TPU, or you can do what I've done here, which is to add single layer supports on the first layer. Because they're just one layer tall, you can easily clip them off after the print, but you need to make sure to avoid putting them on curved parts of the design, because you don't want to have to cut off around a curved shape. So to do this, you would just need to extrude those parts to your print layer height, which is usually something like 0.2mm, that's what I use. So you extrude them to 0.2mm and then they will only take up one layer, and then you can clip them off afterwards. Also, when I printed circular stamps without the outer rim here, and also when I had a thin outer rim, I found that what happened was they peeled up off the base mid-print. It would curl upwards at the edges, and then it would just come off entirely. You could solve that by a design like this, which is kind of like a ring around the edge connected by a few single layer thick joining pieces. Again, these are easy to cut off afterwards, and this solved that problem entirely. So as you can see, at this point I've basically sorted this method of making stamps. If I wasn't doing a video, I would just stop here and consider this a success. But there was one more method that I wanted to look at. After my previous video, one of the viewers suggested that I should sand down stamps after making them, and this would apply to the stamps that are made face up. So I printed out the same stamp face up, and I took some 320 grit sandpaper to it. Now TPU doesn't appear to sand very well, as you might expect, it's sort of a bit squishy, but after maybe 10 minutes of just rubbing the stamp on the paper gently, I saw a huge improvement in the performance of the stamp. So the viewer was right, thank you very much for the advice. Sanding stamps absolutely does work, and this result is almost as good as printing face down. If you had a design that you couldn't print face down, or a textured bed that isn't glass, then sanding is absolutely a good alternative method to use. So anyway, the last couple of stamps I made were rectangular, and these were largely done as props for this video and just extra examples so you could see that you can make them. Making a permanent rectangular base wasn't too hard. You just extrude a rectangle and then create an offset plane between the two shorter sides, and then draw the same kind of handle shape on it and revolve it to create a compound shape. Try to spread as much of the handle's load onto the base as possible so that you don't have a weak handle and also you get good equal pressure when you're stamping, but that is all there is to it. Finally, I pushed the boat out with the stamp you saw in the intro. Nothing too tricky in terms of design, it's mostly text, but I want to mention that this stamp printed out perfectly first time as well, so I definitely do recommend trying my profiles out. By the way, I've never actually shared Prusa Slicer profiles before, so if you have any trouble importing them at all, it's probably my fault and let me know. Well, that brings us to the summary of the video, and don't tune out at this point because I know you all do, I've seen the graphs, but I've got some important advice, or at least in my opinion. Firstly, you can print TPU stamps either face up or face down, but face down requires less post-processing, but it is also harder to pull off successfully. Sanding is best done with a fine grit, just go at it for a few minutes in a circular motion. Don't bother with any non-flexible material, it just doesn't work. Use supports when printing face down and clip them off afterwards. Keep designs bold and simple. It's actually important to design a stamp from the ground up. If you try and use an existing design that has too much detail, it just won't work out well. I know it's a hassle, but that's just how it is. One thing I haven't mentioned up to this point, but I think it's worth stating, when you're stamping with this kind of stamp, something you have to do is take a bit of time over it. You can't just whack it down like a library date stamp and get an imprint. Any of us that are old enough to remember library books being stamped like that. But you have to spend some time loading the ink up, and then you have to kind of push down to apply even pressure to the paper and then slowly lift it up. That's just how you do it with these kind of stamps. And finally, as I already mentioned several times, all the resources and profiles used in this video are shared on my new website, see the link below. Well, that's it. I think I could probably put stamps absolutely to bed now. Finally, I have achieved what I wanted to in the first episode. Let me know in the comments what you think, or if you've tried yourself and whether it worked out or not. Remember to subscribe and like, and thank you for watching.